Okay, a student, actually more than one student, said that they were having trouble with inclined plane. So why don't we just take a few minutes sort of to lay out the basics of the inclined plane and then sort of some of the caveats that you might run into, because you will encounter it on your exam. It's a very important thing to understand because it involves 2D forces, it involves Newton's second law, Newton's laws as we understand them. So let's just start with a basic inclined plane. Have an inclined plane like this. Let's just give this an angle. I'll say it's 30 degrees. And then I have an object that sits on this inclined plane. And a couple of things to note here. First of all, this object sitting in the inclined plane, for the time being, we'll say there's no friction. We want to draw our coordinate system. First, we'll just label all the forces. And these are the forces that are always acting on this block. Now I'm going to draw all the forces as if they're acting at this point. Okay, we really know that the forces are acting at the center of the block, but we'll just draw it for ease here. We'll draw it here. All right, so this force is always acting. This is the weight, and then this is the normal force. These two forces are always acting. And we'll just leave it at that for the time being. And now we'll draw our coordinate system. We want to always draw our x-axis along the plane of the incline, and we'll always draw our y-axis along the perpendicular to that plane. So this is y, and this is x. So that's it. Now, let's say I just asked the question, how fast is this thing accelerating? Well, then I'll go through my steps. I've already drawn the coordinate system. I've labeled all the forces. Now I need to determine what is this angle. Now notice that I have a right triangle here. Because this angle right here is 30 degrees, I know that this angle has to be 90 degrees. Or excuse me, not 90. I know that this angle has to be 90 minus 30, or 60 degrees, because that's a right triangle. Okay, so I can redraw my coordinate system here. I have my normal force. My normal force is acting right here. That's my normal force. And then notice that my force weight is right here, and my force weight is at 60 degrees from the axis. Now my next step is that I want to resolve that force weight into its components. So do that down here. I'm going to draw another coordinate system. You probably won't have to do this, but just for clarity, I'm doing it here. So here I have my x component of my force weight. It's equal to the force weight times the cosine of 60. And I'm the y component of my force weight. That's Fw sine of 60. And then I have my normal force. Now, because of the way that we've drawn our coordinate system, where the y-axis is perpendicular and the x-axis is along the plane, our motion, if we have motion, will only ever occur on the x-axis. That's why we draw our coordinate system that way, because it makes the problem a lot easier. If we were to draw the coordinate system in a different way, the motion of the block, which is along the inclined plane, would be both in the x and the y-axes. So for example, if we drew our coordinate system like this, our acceleration vector would be in this direction, so it would have both x and y components. All right, so that's why we do that. Now I apply Newton's second law. I say the sum of the forces in the x direction and the sum of the forces in the y direction in both of these cases, these are equal to MA in the x direction or MA in the y direction. With the inclined plane, because again, the reason that we drew our coordinate system that way is this is always going to equal 0. Sometimes in the x direction it will equal 0, and it will say, like for example, on problem number 5 in the homework, I think the first part of that problem, you had it stationary. We say, well, it's stationary, so therefore it's not accelerating in either direction. It's not moving whatsoever. Okay, so now I can write my equations. I say the sum of the forces in the y direction, Fn is in the positive y direction, Fx is in the negative y direction. That's Fw sine of 60. That's equal to 0. And then the sum of the forces in the x direction, well, that's just Fw cosine of 60 is equal to max. So from these, I can say, well, the normal force is equal to Fw sine of 60. And here I can say, if I want to know, for example, what is the acceleration, I can say the acceleration in the x direction is Fw cosine of 60 all over the mass. So it turns out, in fact, that this is just equal to g cosine of 60. Remember, because Fw is m times g, and that mass cancels out. All right, so that's sort of the basics of the inclined plane. I'm going to pause here, and then I'm going to address something else.